There is a massive metal contradiction sitting in the motor pools of the United States Army, and it is currently causing one of the most interesting identity crises in modern military history. If you were to walk up to this machine on a muddy testing ground at Fort Liberty, your eyes would immediately tell you exactly what you are looking at. You would see a set of heavy steel tracks churning up the earth. You would see a heavily armored hull capable of deflecting cannon fire. You would see a traversing turret mounted with a massive main gun capable of leveling a building from 2 kilometers away. Your brain would instantly categorize this vehicle as a tank, but if you were to say that word in front of the program managers or the doctrine writers at the Pentagon, you would be swiftly corrected. They would tell you, with a straight face, that this is absolutely not a tank. This vehicle is the M10 Booker, and officially it is designated as the Mobile Protected Firepower, or MPF. The Army's insistence that the Booker is not a light tank is not just bureaucratic stubbornness or a semantic game. It is a desperate attempt to prevent history from repeating itself in a way that gets soldiers killed. For decades, the United States infantry has had a gaping hole in its formation. When light infantry units, those airborne troops dropping from the sky, or light divisions moving rapidly through difficult terrain, encounter an enemy bunker, a fortified machine gun nest, or a light armored vehicle, they often have to stop and wait. They have to wait for air support that might not come, or wait for heavy Abrams M1 Alpha II tanks that are too heavy to cross the local bridges. The M10 Booker was built to fill that gap. It was built to kick down doors for the infantry. But here is the central conflict that makes this machine so fascinating. To build a vehicle light enough to travel where the infantry goes, you have to strip away the one thing that makes a tank, which is the ability to take a hit from another tank. The designers of the Booker have created a machine that looks like a heavyweight prize fighter, but has the jaw of a middleweight. It carries the firepower to kill almost anything on the battlefield. But if a commander gets confused by its silhouette and sends it to fight main battle tanks, the M10 will burn. This tension between the immense firepower it carries and the fragile tactical niche it occupies defines every single bolt, weld, and microchip in its chassis. The story of the M10 Booker is really the story of a ghost. For nearly 30 years, the U.S. Army has been haunted by the retirement of the M551 Sheridan. The Sheridan was the last true light tank employed by American forces, seeing extensive combat in Vietnam and later in Panama and the Gulf War. It was an aluminum box filled with high explosives that could be dropped out of an airplane, but it was flawed, dangerous to its crew, and made of armor that sometimes caught fire when hit. When the Sheridan was retired in 1996, it left the infantry without a dedicated big gun. Programs to replace it came and went. The M8 Buford was canceled just as it was ready for production. The Future Combat Systems program burned through billions of dollars without yielding a fielded vehicle. The infantry was left to rely on the Stryker mobile gun system, a wheeled vehicle with a high center of gravity and an autoloader that jammed so frequently the crews hated it. So, when the Mobile Protected Firepower program was launched, the pressure was immense. The Army needed a solution, they needed it fast, and they needed it to work. They did not want a science project, they wanted a brawler. If detailed technical breakdowns of military design and strategy interest you, subscribe. I have got more of these coming. To understand why the M10 Booker looks the way it does, you have to look at the family tree of the winning bid. The competition came down to 2 titans of the defense industry, BAE Systems and General Dynamics Land Systems. BAE offered an updated version of the old M8 Buford, a classic light tank design. But General Dynamics took a different approach. They looked at their portfolio of existing vehicles, specifically the Austrian-Spanish Ascod chassis, which is used as an infantry fighting vehicle in Europe, and the Griffin technology demonstrator. They essentially took the chassis of a heavy infantry fighting vehicle, stripped out the troop compartment in the back, and dropped a scaled-down version of the Abrams turret on top. This decision to modify an existing infantry fighting vehicle chassis rather than building a purebred light tank from scratch had profound consequences for the engineering reality of the M10. First, let us look at the engine placement. If you look at a standard main battle tank like the Abrams M1 or the Leopard 2, the engine is in the rear. This balances the heavy armor at the front and keeps the heat signature away from the forward thermal optics. But on the M10 Booker, the engine is mounted in the front to the right of the driver. This is a direct legacy of its infantry fighting vehicle DNA. In a vehicle like the Bradley or the Ascot, the engine is in the front to leave room in the back for soldiers to exit. On the Booker, there are no soldiers in the back, but the engine remains up front. This front engine layout creates a unique set of trade-offs. On the positive side, the engine block itself acts as a massive chunk of additional armor. If an anti-tank rocket hits the front right of the hull, it has to chew through the transmission and the diesel engine before it can reach the crew compartment. It is a sacrificial shield. However, this also causes thermal issues. The exhaust and cooling systems are venting hot air right in front of the turret, which can create a heat shimmer that distorts the view of the optical sensors if not carefully managed. The engineers had to design complex baffling systems to route that heat away from the gunner's primary sight, a problem that rear-engine tanks simply do not have. The heart of this beast is the MTU-8 V199 TE23 diesel engine. It generates approximately 800 horsepower. While 800 horsepower sounds impressive for a civilian truck, in the world of armored warfare, it is modest. The M1 Abrams generates 1,500 horsepower. However, the Booker is significantly lighter. Depending on the armor package fitted, the M10 tips the scales between 38 and 42 tons. This gives it a power-to-weight ratio that makes it sprightly, though not exactly a race car. It can hit speeds of 65 kilometers per hour on roads, but its real prowess is in torque. The suspension is a high-drop pneumatic system, which provides a much smoother ride than the torsion bars found on older tanks. This matters because a smoother ride means the crew is less fatigued after 6 hours of cross-country movement, and it allows the fire control system to stabilize the main gun more effectively while moving over rough terrain. But let us talk about the teeth of the M10, because this is where the not-a-tank argument gets difficult to sustain. The Booker is armed with the M35 105mm cannon. This gun is a modernized, low-recoil derivative of the legendary M68 cannon that armed the Patton tanks and the original M1 Abrams. You might ask, why 105mm? Why not the current standard 120mm found on the modern Abrams? The answer is physics. A 120mm gun generates massive recoil forces. To absorb that recoil without the vehicle tipping over or the turret ring cracking, you need mass. You need a 50 or 60-ton vehicle to anchor that kind of explosion. Putting a full-power 120mm gun on a 40-ton chassis is an engineering nightmare that usually requires a muzzle brake, which kicks up huge dust clouds, blinding the crew, or specialized long recoil mechanisms that eat up internal space. Furthermore, the mission of the Booker is not to fight other tanks. Its mission is to blow up concrete bunkers, light vehicles, and dug-in infantry. For that job, the 105mm shell is actually superior in some ways. It allows the vehicle to carry more ammunition. Over 40 rounds are stored on board. The smaller rounds are easier to handle inside the cramped turret. And most importantly, the Army has developed a new piece of technology called the Advanced Multi-Purpose, or AMP, round. The M10 Booker does not need to switch between 4 different types of ammunition. The AMP round is programmable. The gunner can flip a switch to tell the shell to airburst over a trench, delay detonation to punch through a wall and explode inside a room, or detonate on impact for maximum blast. This versatility means the M35 cannon is a terrifyingly efficient tool for dismantling fortifications. The fire control system that directs this gun is almost entirely lifted from the Abrams M1 Alpha 2 System Enhancement Package version 3. This is the brain of the tank. It includes the commander's independent thermal viewer, which allows for hunter-killer operations. While the gunner is looking through the main sight to destroy a target, the commander can be scanning for the next threat with a completely independent 360-degree thermal camera. Once the commander finds a target, they push a button, and the turret automatically snaps to that bearing. Giving this level of sophisticated optics to a light support vehicle is a game changer. It means the M10 Booker can see the enemy long before the enemy can see it, especially at night or through smoke. However, there is a human cost to the design choices inside the turret. Unlike almost every other modern light tank in the world, such as the Chinese Type 15 or the Russian Sprut SD, the M10 Booker does not have an autoloader. It has a human loader. This means there is a fourth crew member who has to physically pick up the shell and shove it into the breech. In the tight confines of a 40-ton vehicle, this is physically exhausting work. The decision to keep a human loader was controversial. Autoloaders save space and weight. But the U.S. Army argued that the fourth crew member is essential for maintenance. When a track breaks in the mud, or when the engine needs to be serviced in the field, having 4 sets of hands instead of 3 is a massive advantage. An autoloader cannot help you change a thrown track link in the pouring rain. A private first class can. Let us transition to the most sensitive topic, protection. This is where the M10 Booker pays the price for its mobility. The hull and turret are constructed from high-hardness aluminum alloys with bolted-on steel and composite armor panels. This modular approach allows the armor to be upgraded or replaced if it gets damaged, or if newer, lighter materials are invented in the future. But make no mistake, this is not Chobham armor. It is not the impenetrable, depleted uranium mesh found on the Abrams. The frontal arc of the Booker is designed to withstand 30mm cannon fire and perhaps older anti-tank rockets. The sides and rear are vulnerable to much less. If an M10 Booker turns a corner and faces a T-72 or a T-90 main battle tank, the Russian tank's 125mm gun will punch through the Booker as if it were made of paper. This brings us back to the doctrinal crisis. The protection is sufficient for what the Army calls small arms and shrapnel, but in a world proliferated with varying types of drone warfare and top attack munitions, the Booker is a large target. It relies on killing the enemy before they can fire or using the terrain to hide. It cannot stand and trade punches. This vulnerability drives the not a tank nomenclature. If a battalion commander thinks of the Booker as a tank, they might place it in a blocking position on a road. That is a suicide mission. By calling it mobile protected firepower, the Army is trying to rewire the brains of its officers to treat it like a mobile pillbox destroyer, flanking the enemy and supporting the infantry, never leading the charge into heavy armor. Yet, despite the fancy doctrine, once this vehicle hits the mud of the real world, things get messy. We need to talk about where the M10 Booker is actually going to fight. The strategic pivot to the Indo-Pacific means the Army is preparing for island hopping and jungle warfare. The M1 Abrams is simply too fat for this theater. At over 70 tons, the Abrams cannot cross most of the bridges in Southeast Asia. It sinks in soft rice paddies. It is a logistical nightmare to ship across the ocean. The M10 Booker, at roughly 40 tons, can cross significantly more bridges. 2 of them can fit inside a C-17 Globemaster transport aircraft, whereas only 1 Abrams can fit. This means an airlifted response force can bring twice the number of guns in the same number of planes, but 40 tons is still heavy. The original requirement for the Mobile Protected Firepower program hinted at a vehicle that could be airdropped like the old Sheridan. That dream died quickly. Physics simply does not allow for a vehicle that is light enough to float down under a parachute, but armored enough to survive a modern battlefield. So, the M10 is air transportable, not airdroppable. It has to land on a runway. This creates an operational bottleneck. To get the Booker into the fight, you need to capture an airfield first. This limits its utility in the initial hours of a forced entry operation compared to the old Sheridan, which could drop right onto the drop zone with the paratroopers. The Booker will arrive in the second wave. Knowing what you now know about its performance in the field, do you think the design trade-offs were worth it? Share your thoughts below. When we compare the M10 Booker to its peers, the picture becomes even more complex. Its primary rival is the Chinese Type 15 light tank, often called the Black Panther. The Type 15 was designed specifically for the high-altitude plateaus of Tibet and the dense jungles of the south. It is lighter than the Booker, weighing in at roughly 33 to 36 tons. It has an autoloader and a 3-man crew. The Chinese tank also carries a 105mm gun, but it includes the capability to fire gun-launched anti-tank guided missiles, extending its range beyond that of the conventional shells used by the Booker. On paper, the Type 15 looks like a serious threat. It is lighter, potentially more mobile in extreme terrain, and has missile capability. However, the Booker holds the advantage in situational awareness and survivability. The 4-man crew of the Booker provides a distinct cognitive advantage. In intense combat, the commander of a 3-man tank is often overloaded, trying to command the vehicle, talk on the radio, and help the gunner find targets. In the 4-man Booker, the loader takes the physical burden off the crew, and the separation of duties allows the commander to focus purely on tactics. Furthermore, the fire control systems of the U.S. Army are generally considered superior in their thermal resolution and stabilization, allowing the Booker to fire more accurately while moving at speed. Another point of comparison is the Swedish CV-9105. This is a highly capable light tank built on the CV-90 chassis. It is very similar to the Booker in concept. However, the Booker's integration into the U.S. Army's digital network is its secret weapon. The M10 is not fighting alone. It is a node in a massive network. Through the Blue Force tracker and other data links, a Booker crew can see targets identified by drones, Apache helicopters, or forward observers miles away. It can engage targets without ever visually spotting them itself, using indirect fire techniques if necessary. This digital backbone is what truly separates American hardware from many of its competitors. But technology introduces fragility. The sheer complexity of the electronics inside the Booker means that field maintenance is a nightmare of diagnostic laptops and replaceable circuit boards. In the humid, corrosive salt air of the Pacific or the dusty environments of the Middle East, keeping these thermal sites and data links operational will be a Herculean task for the maintainers. The old tanks could be fixed with a wrench and a sledgehammer. The Booker requires a software update. Crew feedback from the early testing units at the 82nd Airborne Division has been a mixture of awe and frustration. The crews love the firepower. For light infantry soldiers used to walking everywhere with nothing heavier than a machine gun, having a 105mm cannon responding to their calls is a godsend. They appreciate the thermal optics which turn night into day. However, they have noted the cramped interior. Because the turret is a scaled-down Abrams design sitting on a narrow hull, the internal volume is tight. The loader has to be almost acrobatic to retrieve rounds from the ready rack and pivot to the breech without hitting the commander's knees. There is also the issue of the skylining silhouette. The M10 Booker is a tall vehicle. Because the engine is in the front and the hull is based on an infantry carrier, the roofline is quite high. Then you add the turret on top. In a hull-down position, it is manageable, but when moving across open ground, the Booker presents a large vertical profile. In the age of anti-tank guided missiles, being tall is dangerous. The designers have tried to mitigate this with superior situational awareness, spotting the missile team before they fire, but the physical size remains a liability. One of the most interesting hidden features of the Booker is its suspension tuning. While it uses tracks, the acoustic signature is surprisingly lower than an Abrams. The rubber-padded tracks and the modern diesel engine make it quieter than the turbine whine of the main battle tanks. This acoustic stealth, combined with its smaller thermal footprint, allows the Booker to move somewhat more discreetly. In exercises, Bookers have managed to ambush opposing forces who were listening for the distinct roar of an Abrams and failed to hear the diesel hum of the approaching light tanks until it was too late. The naming of the vehicle is also a break from tradition and carries deep weight. Usually, tanks are named after generals: Sherman, Patton, Abrams, Sheridan. The M10 is named Booker, but it is not named after a general. It is named after two enlisted soldiers who died 70 years apart. Private Robert Booker was a Medal of Honor recipient in World War II, killed in action in Tunisia while suppressing machine gun fire to save his squad. Staff Sergeant Stephen Booker was a tank commander killed in action during the Thunder Run into Baghdad in 2003. By naming the vehicle after enlisted men, a light infantryman and a tanker, the Army is physically manifesting the hybrid nature of the vehicle. It is a tank designed for the infantry. It bridges the gap between the two worlds. As we look at the long-term assessment of the M10 Booker, we have to circle back to the central question: is it a tank? Technically, by every definition of automotive and ballistics engineering, yes, it is a tank. It is a tracked, armored fighting vehicle with a turret and a large caliber gun designed for direct fire. The Army's refusal to use the word is a psychological guardrail, a doctrinal safety mechanism. But this safety mechanism might fail. In the heat of combat, when a perimeter is being overrun, a commander is not going to care about the official designation. They are going to see a tank, and they are going to order it to do tank things. They will send it to hold a crossroads against enemy armor. They will send it to charge a line. And when that happens, the Booker's thinner armor will be tested. The success of the M10 will depend entirely on whether the crews can use their superior speed and sensors to shoot and scoot, to fight unfairly, and to never let the enemy take a fair shot at them. The M10 Booker represents a shift in American warfighting. It acknowledges that the days of the invincible heavy tank sweeping across the plains might be limited to specific theaters. In a world of urban sprawl, crumbling infrastructure, and expeditionary warfare, the heavy sledgehammer of the Abrams is often stuck at the port. The Booker is the dagger that can actually make it to the fight. It is imperfect. It is a compromise of weight, protection, and firepower. It is too heavy to drop from the sky, but light enough to cross the bridge. It is vulnerable to tank fire, but lethal to everything else. Ultimately, the M10 Booker is a gamble. The Army is betting that seeing the enemy first and hitting them with precision high explosives is more important than being able to take a hit on the chin. They are betting that the infantry needs a bodyguard more than they need a bunker on tracks. Whether that gamble pays off will only be known when the first M10 crew finds themselves staring down a jungle road in the Pacific or a dusty alleyway in Eastern Europe with the safety off and a round in the chamber. It may not be called a tank on paper, but when the trigger is pulled and the 105mm cannon roars, the enemy certainly will not be debating the terminology. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.